All right, let's talk about the one topic in C that everyone seems to fear: pointers. I know, just hearing the word can be a little intimidating. But what if I told you they're not nearly as complicated as they seem? In fact, by the end of this, you're going to feel like you have a genuine superpower: the ability to directly control your computer's memory.
So here's our game plan. First, we'll start with a super simple analogy to get the main idea down. Then, we're going to get our hands dirty with the actual code. From there, we'll see how this stuff is actually used in the real world. And finally, we'll tie it all together to understand why pointers are the secret behind C's legendary power.
All right, first things first. To really get this, we're actually going to forget about code for just a second. Trust me on this.
So what is a pointer? At its core, it's just a variable that holds an address. That's it. Think of it like this. If you write 123 Main Street on a sticky note, that note doesn't contain the actual house, right? It just tells you where the house is. Pointers are exactly that. They're the sticky notes for your computer's memory.
See, every single time you declare a variable, like int value equals 42, your computer does something behind the scenes. It finds a little empty box in its memory, sticks the number 42 inside, and slaps a unique address on that box so it can find it later. And this visual just nails it, right? We have our box, we've called it value, and inside there's the number 42. But the really important part is where it lives, at memory address 0x7ffc. That's its home. Simple as that.
Okay, so we get the what. Now let's jump into the how. How do we actually play with these addresses in our code? This is where we learn to speak the language of memory.
You really only need to master two special symbols. First step is the ampersand, the and symbol. Think of this as the address of operator. You stick it in front of a variable and you're basically asking, hey, where do you live? Then there's the asterisk, star. This is the opposite. It's the go-to operator. You give it an address and it goes there and fetches whatever is inside.
And here's what that looks like in code. We're declaring a new variable, PTR. That little asterisk tells the computer, hey, this PTR variable isn't going to hold a regular number, it's going to hold the address of an integer. And what address do we give it? We use the ampersand on value. So we're literally telling PTR, your only job is to remember where value lives. This visualization makes it crystal clear. Our original value box still holds 42, but look at the new PTR box. It doesn't hold 42. No, it holds the address, 0x7ffc. It's literally pointing right at the value variable.
Now for the magic. If we want to get that number 42 back, but all we have is our pointer, we just use that asterisk again. Writing star PTR tells the computer, go to the address that PTR is storing, open up the box you find there, and tell me what's inside. And what's inside? Of course, it's 42. This is the perfect way to remember it. The pointer is the address on the piece of paper, and using the asterisk is like driving to that address and knocking on the door to see who's home. Okay, theory's cool and all, but why should you care? Let's dive into some real-world code. This is where you're going to have that big aha moment and realize this isn't just some weird trick, it's an essential tool.
Here is a classic problem pretty much every programmer faces. You write a function and you want it to actually change a variable from somewhere else in your program. But by default, functions just get a temporary copy. They can change the copy all day long, but the original variable is left untouched. So how do we fix that?
Pointers to the rescue. Look at the left side. That's the normal approach. Pass by value. The function gets copies and the swap fails. The original x and y are unchanged. But now look at the right. Instead of passing the values, we pass their addresses using that ampersand. Now the function has the real location of x and y. It can reach out and modify them directly. The swap works.
Okay, another place where pointers are a total game changer is with arrays. Here's a little secret of C. The name of an array is basically just a pointer to its very first element.
This means we can just create a new pointer, let's call it PTR, and aim it right at the beginning of our array. Simple as that.
Now here's where it gets really cool. Instead of using an index like array at 1, we can just do math directly on the pointer. It's called pointer arithmetic. When we say PTR++, we're telling the pointer to just slide over to the memory address of the next element in the array.
And again, for the next one. This is an incredibly fast, low-level way to just walk through a chunk of data in memory. And this is absolutely fundamental to how C handles text. Because what is a string in C? It's just an array of characters. So pretty much any string operation you can think of, copying, searching, you name it, is using pointers under the hood to walk through that character array.
Okay, so let's zoom out for a second. We've seen what pointers are and how they work, but the big question is why? Why are they so central to C? Why does this all matter so much? Well, it really boils down to two things: raw speed and absolute control. By using pointers, you're talking directly to the computer's memory. There's no middleman, which makes things incredibly fast. This also gives you the power to manage memory dynamically, grabbing it when you need it and releasing it when you're done. This is the bedrock for building seriously high-performance data structures like linked lists or trees from scratch. And that right there is the secret sauce. That raw, unfiltered access to memory is exactly why C is the language of choice for anything that needs to be as fast and efficient as humanly possible. We're talking operating systems, high-end video game engines, the tiny embedded systems in your car or your smartwatch. They all run on C because of the power that pointers give you. So there you have it. What started out as this intimidating, confusing concept is really a key that unlocks a whole new level of programming. You're not just writing instructions anymore. You're speaking the language of memory itself. So the only question left is, now that you have that key, what are you going to build with it? Thanks for watching.